Good morning. My name is Kelvin Chu. Welcome to the C2 Smart sponsor webinar. Today we have a distinguished speaker, Professor Pavel Hubes. He is the Dean of Faculty of Transportation Sciences at Czech Technical University, and he's going to talk about the application of Geographic Information Systems for urban mobility in the Czech Republic. Professor Hubes, please.
Thank you. Thank you for short introduction. Good morning, ladies and gentlemen. I'd like to say thank you very much, UTEP, for inviting me to this webinar and to have a possibility to give you some taste of our work in Czech Republic, what we are doing at the Faculty of Transportation Sciences, Department of Transport Telematics. The presentation outline for today, I'd like to give you some information about me, about my personality. Then I have a very short, brief introduction to the Geographic Information Systems, to these that are not familiar with them. And then I like to present two projects which we are working on. One of them is already done. It was the database design, and the second one, it's a system for monitoring of traffic flows in Czech Republic, and this project is still running. So, about me, I was working during my master studies for the Intergraph company, the United States company. Currently, it's named Hexagon, and I was there as a application specialist for GIS and CAD systems. After my graduation, I was working for GCR private company in Czech Republic. This was also company which was working in the field of GIS. Since 2004, I'm employee Czech Technical University Faculty of Transportation Sciences. I had a long way from junior researcher as then associate professor, head of department, and nowadays I'm a dean of the faculty. And since 2018, my second position, which is very important in Czech Republic, it's a chairman of management board of the Railway Infrastructure Administration. So I'm also very close to the railway system in Czech Republic. This company has more than 17,000 employees, so it's one of the most important company in the railway industry in Czech Republic. To my scientific focus, because of Department of Transport Telematics, I am close to the intelligent transport systems and all kind of information systems which should be applied in transportation domain. So the functionalities like the traveler information systems, simulation, travel domain modeling, and so on. And personally, in this field, I'm very close to the GIS application, so how to maintain the spatial information and so on. So that's what I like to do. I also like to introduce my PhD thesis topic here. That was, I think, about 20 years ago. We were thinking about possibility if we are able to recognize the geographic information layers meaning only based on the spatial analysis of them. So I put to this presentation the pictures here, which is about the two layers. So we were maintaining there. The upper layer was about the crossroads in Czech Republic, the point layer with the information about the crossroads, and the lower layer was about the villages. So the point information in Czech Republic about the villages, and you can see the differences and the other pictures, how differs the these layers is almost similar counts of the features, so similar count of the crossroads and similar count of the villages, and they differs in a spatial characteristic done by J functions and G functions, and there is also distance analysis between these objects in the geographic information system. So I was trying to looking for these characteristics, spatial characteristics, and then find the neural network systems which should recognize these differences and classify which one layer should be to have find the meanings of these layers. So next to the geographic information systems, here is I think well-known definition done by Warburg and Dunham in 2004. So the geographic information systems, it's computer-based systems and enable us to capture, modeling, storage, sharing, and manipulation all kinds of data which are related in geographic references. So something which I think it's very important for us, because in the past or very often you see the system that maintain the time series and the tables with time series, and here we are adding the new dimension, the spatial dimension, which gives us much more possibility what to analyze and how to work with the data. It is a very smart concept how we are working with it. If here is a picture that the lower level, it's the reality, so what we can see around us, and what we are trying to do to have a model in layers, and each layers is according to some world phenomenon. So here, for example, there is a layer of the streets, layer of the buildings, layer of the crimes, and we have a possibility to combine these layers together at one model and use these models together and looking for interferences between them, so looking for the connections between these layers on a spatial view. So it's a really possibility, or it's give us much more possibilities what to combine together and what analyze to do. It's very important that each layer should be maintained by different companies and different systems. So that's very powerful that we are only join this data together and we are working on it. And the owner and maintainer is the company which knows much better how to work with it. So, for example, the crime, it's the layer which maintain probably some police departments or statistical departments in the police. The buildings also, that's part of the government, so some infrastructure maintainer and so on. And we are using this layer. We don't need to taking them in a space, but we are only use them as a model and putting them together. It enable to us really to do a very powerful analysis. So what's the principles of the modeling that our world? It's infinitely complex. So what we need to solve in this issue is to simplify, to reduce the information from the real world to these models. We are, of course, looking for the best, simplest model that we can connect to the reality. And one of the powerful functions of the GIS is that you can have there the digital version of the real objects which are present at this time somewhere, but you can also have there the objects that are virtual, so something like the boundaries or country borders and so on. But also you can add there the planet infrastructure object, or something what would be in the future, or something what was in the past. So it's very powerful that we can change the conditions in these models, that we can prepare some future state, then start our analysis and get a probably future future outputs which will come if we build something in a reality. So very powerful that we can combine the sources, and we also should think about the future of it. How hard it is, here is a simple presentation about what we do, how we transfer the reality to the model, and how hard it is. That on the left side you see the picture of the forest, and what we are looking for very often to find some border. So the model of this border, this, where is a forest, and for example count the area of this forest, so square meters. And it is really not simple because it's to find this border very often it's take we must find some functions. For example, uh, something like to look for 5 trees per 10 square meters, and say if it is more, then it is a forest. If it's lowest value, then there is no forest. So uh, and it is up to us which one of this function we take, and it is up to us how we will set this model. And it's very important to, if we are thinking about this analysis, that really these models are not true always. Always is there some percentage of probability. So it's similar with the GPS positioning, that you cannot say that you are standing at some position as a true. You always have some probability that you are at this position. So here it is very similar, that you must taking account this probability of the truth of these maps and working with them in this way. So to our project, what we did and what we are running now. We has, I think, a very strong cooperate with the national organization Road and Motorway Directorate. It's the most important organization in Czech Republic in the road and motorways field. They are maintaining all first-class roads or motorways. So they are working in a field of all Czech Republic. So it's for us as CTU, it's nice to be close to them and see what they do, and try to help them. So we are having 2 projects. The first one was about the database design. If I will continue to the first slide about it. So we was invited to analyze the GIS data model, what they are using, and provide them by some advices what they should do better, or how to bring them some development in this field of area. So they give us their model, what they used every day, and they were asking us to bring them some new advices, what they can do with them, and identify some critical points of current database, and give them the new design or possible data model which they can use. It was very interesting work for us. It was done in years 2016 and 2017, and at the end we really prepared a new data model which they can nowadays use. So first what we did was to look around the sources and the organization which are working in this field. So the OECD, PRG, TRB, and this organization which are very popular in these fields and give advices on the world level for this organization. So as we had a possibility to analyze these databases, we found that they are used free databases, free data models which differs, but they are partially overlaid. So that was something was not so useful, and we also found that they don't update it, these databases at the same level. So we found that the same features in these databases had not updated information together. So that was very important for us to know that it's really necessary to find some uniform database or a uniform data model which will be updated only once for all kind of field what they used. And as we found in these databases, they only collect the data about the technical aspects. So only technicians are putting their updates and information, and they don't use these databases, for example, for some budget expectations or for some accounting aspects, for some strategic idea. They only use them as a technician to save the data about the network and work with this only in the technician way. So this was for us also the important information that we recommend them extend their data models to work also in the field of strategic ideas and the ideas about the budgets. So what we did at the end, that we take these three models, find the features which are alike, and combine these models together to do one of it. We found it that it's possible to model 37 objects in the database, and we prepared information on how much frequency is necessary to monitor them and how to keep them in update. Sorry that here is a picture in the Czech languages. All kind of features in these models are here mentioned in Czech, but hopefully if you will need the translation, tell me and I can do that for you. So here is a one list which described one of the feature in a database. There is a definition of it. There is a attribute information which we recommend to collect about them, and also we put them the picture which shows what kind of typical object in a real world should be put in a database as a feature in this class. So we also check the current standards and legislative information. So we recommend modified some terminologies according to these valid standards. We recommend to add some new objects to the databases, and also to add the attributes which are related to the time. So there was nothing about the date of realization, construction, installation, and so on. So we added these attributes to all features in the database to be able really use them much more for analysis in the fields of economics and management of these systems. Yeah. Now to the system for monitoring of traffic flow, the second one project which is now still running. So we were invited by the road administrator to be advisor, and for us was really nice that from first time what they were working on this project. So we were really advised by preparation of this system, then during the implementation, and nowadays we are advised by the operation of this application. And the main topic of it is how to incorporate it, the so-called floating car data. So that's our data from moving vehicles on the networks. There are the GPS positions and other information about the speed and the type of vehicles and so on. So how this type of data incorporate in current systems, which is installed in this company, and how to incorporate it in this functionalities. So I think very nice project for us to have a new type of source of data, because in previous time we always working with the loop detectors, so to have a possible to check the speeds and intensity of traffic flows in such places. Nowadays, there is a possible to have a much more information about whole network, and it brings the possibility to do the new analysis and new research about this type of data. So for them was the main information what they are trying to gain. It's a duration and formatting of congestion. They are interested in traffic flow speeds and occurrence and duration of delays. So many of the applications are going to the checking the travel time, and they recommend the right ways for the vehicles, which one part of traffic network to use be to have a shorter time from start to destination. So project is not is still running. Here, I'm sorry, also in Czech, it is a system architecture of this project. Very important for them was a left block where is a module which do the anonymization of the data. So that means that there is no possible to track longer time these vehicles. They use the 1 hour changing the IDs of the vehicles. But at other side, we as advisors, we recommend this company also to have a possibility to check how many cars is included in the systems, because there was one of feature of the contract between implementing company and the directorate that there must be more than 150,000 car in a system. So there was a necessary at one side to have a anonymization, and other side to have a possibility to really count how many vehicles it's included. So we recommend them to have two separate data streams. The first one, it's where are information about each car, about the speed, about the position, and so on. And there, the IDs, it's changing every hours. And there is another stream of data where only the IDs of the cars, but they are the long time IDs. So in this data stream, it's possible to analyze how many cars it's included in this stream. Yeah, the other boxes which are here, they are about the computing with this data. There is a long time analytical model which enable to shows the time series and look for the analysis in a longer time. There is a module which present the data. So that was everything what they want to incorporate as a basic functionalities. And the module downstairs, they are related to the historical databases, so to store the data for a longer time. And also very important functionalities was the quality control of these data streams. So that from our side was the recommendation to for all kind of inputs these data have some KPIs, and at the end we were as a CTU the party which developed these checking systems of these KPIs and the quality of the data which they are which they have as input in the systems, and also as an output which is computed by the company. Yeah, here very shortly, what we see as the main functionalities, how to make a match mapping of the position of the vehicle of the network. So the company propose several strategies what they do, and we think that it's quite good strategies, that they are not oriented only at the one point for each car, but they are tracking the longer trips, and they are matching these longer trips to the network, and then they incrementally compute the right right speeds and right informations to the network. Yeah, still, I think it's a functionality. It should be improved. So we are looking for the new possibilities of algorithm how to do that, and it's open for research. So here is what they compute as an output from this floating car data. So for each segment of the network, we are interested to know the current number of floating cars in a partial time time what was there. So we are using the 1 minute scale. So for each segment in 1 minute, it's counted the number of passenger and freight cars there. It's calculated the traffic flows, which is the average speed of these cars which were present there. There is also the travel time through this defined segment. There is counted the delay, which is the difference between the typical free travel time and the current time on the segment. There is also the long typical average speed on this segment as a parameter, and parameter of occurrence of congestions. That's only the yes and no if it's the segment the congestion. Reliability, so that's a functions which counts from how many cars was counted, these parameters like the traffic flows and the others. There is a system reaction. It's related to the time, how old are the data which were obtained from these floating cars, because yeah, it should stays for a longer time that there is no car present. So how old are this information, and there is also computed the level of services on this segment. Another functionality is there the directional decomposition. So from this data, from floating car data, it's possible counting the directions on so intensity of cars in such directions on the crossroad and so on. So that's something what was also interesting for the directorate of the motorways to see it. Yeah, at this time it's open for public the implementation of this data. It's not yet open for everybody. Here it's developed, and here it's a private link of the company. So I try to show you if it's possible to see it. I'm not sure if we are connected to the okay. So here is a Czech Republic. You can see the highways now on the maps. So for each segments on the highways, you can look at it. There is a time of there's a delay or time of you can go through this segment. There is a speeding for this segment, and there is a probability how quality this information is. Also, you can see the information about the congestion, if it's there or not. So here you can see that everything is quite good. The speeding is as uh, 112 kilometers per hour, which is close to maximum 130, which is on Czech highway. So quite good information. Maybe in this, yeah, okay. I expect to show one of the cities, for example, which. Thank you very much. We can select some part of networks. Here is the cities in Czech Republic, and we can look, for example, for Brno city. So here you can see how the density of the transport it's much more, and for some such parts of networks you can see that there is a delays more than 3 minutes. The speed is lower than 30 kilometers per hour, and standard speeding is there 121 kilometers. You see that there is also the queue of the cars more than 1.9 kilometers. So that's all kind of information we are gaining from floating car data now. Okay, so as I said, for us it's really interesting to be part of this project, but yeah, if we are thinking about it, we have also some missions from our side. So this at this time the mission it's the long time check correctness of these input streams of data and computed streams. So we prepared the automatic software which analyze this every day, every month, and every year. We are preparing the reports for the directorate of the motorways, and they, because of contracts, they have some KPIs, and use these reports to fit it if the supplier fit these outputs to these KPIs. And our second part of the mission is to check if these models which are computed on the floating car data are really correct. So if the model estimation are really good in a relation with the traffic flows which we can monitor on the loop detectors. So first, what is I think it's the most important information. It's some spatial density on a road network, because yeah, there was a question, real question, because nobody knows if we will take floating car data, so if they will appears only at some part of the network, or if they will all really for whole Czech Republic. So here is a spatial density of information calculated for 1 month. And you can see here the 5 levels of the blue color. That it's the difference is that the lighter colors are there we have a 0 to 20% of information about the network through whole moon, and the darker blue is the road segment where we have information 80 to 100%. So you can see that the main network, the highways and first road classes really have a very good spatial density, that we have 80 to 100% information what is really on the network. So the cars are there present, and it's done for whole month, so every day, every night, 30 days. So it's that was for us very very good answers. That the sources which this company which developed these systems, and which they make a contract, that they are really useful for whole Czech Republic, and they are not only for the cities or some smaller parts. They are for whole Czech Republic. What we do also is that we are looking at each segment and we are looking at the time series on these segments and checking if the model is really working well for the here is the model for the velocity. You can see the whole month. It is April in this year, and you can see there every day is how was counting for these segments the speeds estimation, and here you can see that we found some errors in this model. So that was something what we propose the directorate to ask the company to check why it is, why they are part of the data which gives the same values of the velocity, because we expect that there must be much more changes in this model, and this looks like that there was some errors in the model. So that's real our mission to check these informations, or check these outputs from the models, and ask what the model does, if it's correct on the network. Here, for example, from another segment, you can see that there are also changes like here, so some steps in the time series. But yeah, it should be real in a reality that probably there was some work on the road, so there was a speed more than 120, and at such day they put it down because of reconstruction. So that's something what we must also clarify, if all kind of this information are real, true, and the model is working well. Here, I think the very important part of our work is compare the floating car data and the computation from floating car data to the loop detectors. Here it is a graph for one day. It's the 10th April, and it is at the D1 highway, very close to Prague, and it's in direction to Prague. What you can see, the lines on the graph, they are the three greens. That's our free lines on the highway. The red one are the minute data from floating car sources, and the yellow line, it's a typical speed for this day. So on the y-axis, it's a speed in kilometers per hour, and on x-axis, it's the time. So from midnight to midnight next day. And for us, it's very nice to see that the floating car data model really fits very well the current situation on the road. There was a almost all day traffic jam. The speeding was around 40-50 kilometers per hour. And it's giving also for us the possibilities of the future research. For example, try to accommodate this data for each line. So you can see here that these three lines really differs in the speeding, because probably the right one, right line, it's mostly for freight transport, so it's slower, and left one, or the upper green, it's the fastest line because of personal cars. Another picture which is also giving some information about the traffic jam at one place is on the network, also on the D1 highway. You can see here two lines in the green, and for example here we see that the data coming from floating car are a little bit noisy, so for us it's also possible to think why it is, if it's some stop and go waves, which are well known on the highways, or if it's a feature of the model. So we must really check these data and discuss what was done in reality and what are given by these data sources for us. So yeah, that's the project. But if we have a availability of these data, so we also think about how to use them, or if here I think it's many questions what we can really take in account and do the research. Here are some of them. So for example, if really the current penetration of these floating cars data is sufficient for the adequate description of traffic flows and situation, if the fleet covers this characteristic really adequately day by day or weekdays traffic periodicity and so on, if this fleet operation really adequately is fit to our areas of interest, and also if it's possible involve these data sources as a primary inputs to the traffic controls, for example, variable speed limits, traffic management, and so on. So there is so many questions which we must answer by our research. So here I have a few graphs which are not which were not done in this project, but we did a past research in this field also. So here is a fundamental diagram for 5-minute periods on the highway. So on the epsilon axis, it's the intensity of the car, in x-axis is the speed in kilometer per hour, and you can see here two types of data. The black ones are the floating car, and the red ones are the loop data. And you can see we are using for traffic controls in Czech Republic a 5-minute period, and you can see how the floating car data are at the no more than 10% of the intensity which are coming from loop data. On the right side, there is a epsilon axis where are the intensity for loop data, and on the left side, the epsilon axis, there are intensity of floating car data. So you can see that there is a 20 to 300. So it's less than 10% what we have in a traffic flow. So yeah, these data are too rare, so it's possible to, at this time, we can say that penetration is too low to use them. But it's very interesting that if we aggregate this data in 15 minutes, 30 minutes, and 60-minute period, you can see how the floating car data fit much better this loop data. So for the future, there is an expectation that if we really will be increasing the penetration of the floating cars, that we will able to use them as a primary source. Here on the right graph, it's also very interesting information in lowest intensities, how there is a speeding of floating car data much more higher than the speeding which is coming from loop data. There is our expectation that it's because of the type of fleets, that the cars in the fleets are very often owned by companies, and the drivers, they rather go much faster to be in time than to save money for the fuel consumptions. So that's also possible to think about these features of these two data sources, and then use them by the modeling. Here, yeah, we did some research how it is during the weekdays. So here are the pictures for intensity of on the y-axis is intensity of the floating car data, on the x-axis it's intensity of loop data, and these two colors this differs that the blue one are the night hours and the pink one are day hours. So it's, for example, here it should be seen that in the night for the yeah on the yeah I see that on the right side it's not mentioned here that the right side graph is for the freight transport, and the left side graph is for personal cars. So for the freight transport it's possible to see how for every day of the week, Monday, Tuesday, Wednesday, Thursday and Friday, during the nights we have more than 50% of the penetration, because these cars are really going through the night, and especially these cars which are parts of the fleets, because these companies are interested to know where their cars are. During the days, then we have a lower penetration, so that's the reason why the pink points are going to right side. But for personal cars, we can see how it really differs. That it's much more mixed together, and yeah, that's the reason that probably these fleets are a combination of the private owner and company owners. So their behavior differs. So but still it's a part of research to really know the answers, how the fleets behave during the night and days, and if the penetration of this car in our fleet, in a floating car data source, are enough to have some decisions. Here it is about the possibility to combine the data, for example, the accident rates with the speeds coming from floating car data. So here is a analysis in Prague, how we found the places where traffic accidents occur, and then we were checking the floating car data, how they are affected by these accidents. Another research should differs that if we know where accidents not occur, that we can analyze the floating car data where they are congested. So to see where are congestion really coming from infrastructure part, that here at these places the infrastructure is not enough built to take these flows which are necessary. For us, it's, for example, very interesting to see that these congestions are close to the Czech border, and the reason is that there are the hills. So probably that when they go the tracks, they go much more slower than they are able on the highway somewhere. So these tracks probably they did this congestion because the other cars must through these hills go much more slower behind them. And another possibility of research what we did, it's also something like analyze the transitability of the network. So to look on the delays on the network, and if we should select the different path based on these delays. And here you can see the strongest red. It shows the traditional way or most common taken way between two cities, and the thinnest roads, they are selected only a few times, and so it enables us really to look through the network and find the best way which should be taken. The last slide which shows to this, yeah, there are very small numbers, but it's about the time of travel time between these two cities, and its travel time on the x-axis it's day hours, and the y-axis they are day of week, so from Monday to Sunday. And the colors which are here, the green and red, the green are the shortest times you can travel, and the red one are the longest time you can travel. So you can see that the differences are between two, I think lowest green is some close to the 2 hours and 90 minutes, and the highest red is close to the 3 hours and 51 minutes. So it offers us to select the right path from A to B at exact weekday and exact day hours. So that's from my side all to this research, and I'm sure that this source of data, the floating data, are really very useful for so many applications in traffic and transportations, and we will see if the penetration will growing, then probably they really could be the main sources about the traffic flows on transportation networks. Thank you very much.